For years, the world believed the global chip shortage was finally coming to an end. Factories were expanding, supply chains were stabilizing, and governments were investing billions to prevent another semiconductor crisis. But something unexpected has happened. Just as the industry was recovering, a new shortage is quietly forming again. And the reason is not a pandemic, not a natural disaster, and not even a factory shutdown. The reason is artificial intelligence. AI is now consuming computer chips at a speed the global supply chain was never designed to handle. And this new demand is beginning to reshape the entire semiconductor industry, from manufacturing capacity to global logistics networks. Now, to understand why artificial intelligence is creating pressure on the global chip supply chain, it helps to first understand how semiconductor production actually works. Most people assume chips are produced in a single factory and then shipped directly into electronics. But in reality, semiconductor manufacturing is one of the most globally distributed supply chains in existence. A chip may begin as raw silicon refined from sand. The chip design could come from engineers in the United States. The silicon wafers might be manufactured in Taiwan or South Korea. Packaging and assembly might take place in Malaysia, Vietnam, or China. And the final product could end up inside a server assembled somewhere else entirely. Before reaching a finished device, a single semiconductor chip can travel across multiple continents. This extreme complexity is what makes the semiconductor industry both powerful and fragile at the same time. Many people remember the global chip shortage that started during the COVID-19 pandemic. Lockdowns slowed manufacturing just as demand for electronics exploded. Suddenly, the world needed more laptops, routers, gaming consoles, and cloud computing infrastructure than ever before. The supply chain simply couldn't keep up. Car manufacturers had to halt production lines because modern vehicles depend on hundreds of semiconductors. Consumer electronics companies struggled to meet demand. Even household appliances were delayed because the tiny processors inside them were unavailable. For a while, it seemed like the world had learned its lesson. New semiconductor factories were announced across the United States, Europe, and Asia. Governments introduced industrial policies designed to strengthen domestic chip production. Companies invested heavily to expand capacity. By the middle of the decade, many analysts believed the crisis was fading. But while the industry was rebuilding supply, a completely new demand shock was emerging. Artificial intelligence. Modern AI systems require enormous computing power. Training large models and running advanced AI applications requires highly specialized processors, often called AI accelerators or high-performance GPUs. These chips are far more complex and expensive than the processors used in everyday devices. And here is where the supply chain problem begins again. A single AI data center can require tens of thousands of advanced processors working together. Some of the newest facilities under construction around the world are expected to use hundreds of thousands of chips. This is an unprecedented level of demand. Technology companies building AI infrastructure are now ordering massive volumes of advanced semiconductors, often far exceeding the orders placed by traditional industries in like automotive or consumer electronics. But manufacturing these chips is extremely difficult. Only a few companies in the world have the technology to produce them. The fabrication process requires advanced lithography machines capable of printing microscopic circuits onto silicon wafers with extreme precision. These machines are among the most complex manufacturing tools ever built. Even with massive investments, production capacity cannot expand overnight, and the challenge does not stop with manufacturing. After chips are produced on silicon wafers, they still need to go through a step called packaging. Packaging connects the chip to other components so it can operate inside servers, computers, or electronic devices. For high-performance AI chips, packaging has become one of the biggest bottlenecks in the entire supply chain. In simple terms, factories may successfully produce chips, but they cannot package them fast enough to meet demand. This creates delays that ripple across the technology sector. Another factor making the situation more fragile is the supply of critical materials. Semiconductor manufacturing depends on rare metals, specialized gases, and highly purified chemicals. Materials such as gallium, tungsten, and helium play important roles in chip production. Many of these resources come from limited geographic regions. If supply is disrupted by trade restrictions, geopolitical tensions, or industrial accidents, semiconductor production can slow down quickly. This is where logistics becomes crucial. The semiconductor industry relies on extremely precise global transportation networks. Components must move quickly and safely between design centers, wafer fabrication plants, packaging facilities, and assembly factories. Many of these shipments require temperature control, secure handling, and rapid delivery schedules. Even small delays can disrupt manufacturing timelines worth billions of dollars. This is why semiconductor supply chains are often described as one of the most strategically important logistics systems in the modern world. Now add artificial intelligence into that equation. AI is accelerating demand faster than the industry can expand supply. Manufacturers must decide how to allocate limited production capacity, often prioritizing the highest value chips used in AI servers. As a result, some industries may again face limited availability of certain semiconductor components. The shortage is not identical to the one caused by the pandemic, but the underlying lesson remains the same. The global economy runs on extremely complex supply chains, and when demand shifts suddenly, those systems take years, not months, to adapt. Artificial intelligence is not only transforming software and digital services, it is reshaping manufacturing priorities, investment strategies, and global logistics networks. And once again, a tiny piece of silicon, smaller than a coin, is influencing the direction of the global economy.